Good afternoon, everyone. I hope you had a good lunch. My name is Nussbaumer. I will kickstart this afternoon of sessions. I work at PostFinance for almost 5 years now, managing the Kubernetes platform there. As you can guess from the small flag, I come from Canton du Jura in Porrentruy. I live on a farm with my wife and our young son, and I'm going to talk about our open source tool, TOPF, which we've built and share to the community to help you manage Talos Linux clusters. So first of all, Talos Linux. Who has already installed Talos Linux in this room? Okay, I guess one third. That's good. So I will, for those who already know, this is going to be maybe less interesting. For those who are new to Talos Linux, the idea Talos Linux is an operating system which is completely declarative and immutable and really small package as OCI images and so on. So basically, Talos Linux is the Linux kernel plus machined, which is a bunch of Go controllers that you can read on their repository. And those controllers are there to do all the stuff that you would normally do in an operating system, like managing services with systemd, configuring network interfaces with networkctl and all that stuff. All of that is written in Go in machined, and they also take care of for running kubelets, etcd if it's a control plane node, spawning the static pod manifest for the API server for the control plane nodes, and so on and so forth. And maybe one super important fact is that there is no SSH with Talos. So you don't have to patch SSH when there is a CVE for SSH, which happens as we've learned in the recent weeks. Instead, you have a gRPC API endpoint on port 50,000 that you authenticate towards with mutual TLS. So that's really the steering point for your nodes, is really just a gRPC API secured with MTLS. And so we really like Talos Linux. We are migrating this week. We are completing the test migration, and in a few weeks we are going to migrate production environment as well on Talos Linux. We really like it because it's small, it's declarative, and compared to what we had, which is my next slide, we were managing our Kubernetes clusters which were Debian OSs with kubeadm, and we had basically built something analogous to kubespray. But ourselves, we did that before the kubespray project started, and so it had grew quite large. We went from Kubernetes v1.15 to v1.35 with these Ansible playbooks, lots of task files, almost 2,000 lines of tasks and playbooks, lots of Ninja templates, and lots of stuff that could go wrong, and that was not completely idempotent. Sometimes you would start an upgrade, it would fail mid-course, and then the next run would miss. For example, one of the control plane nodes would not have been abated. So lots of workarounds, lots of sleep. We were not really happy about it, and that's really why we really prefer to be moving towards Talos now. And so we had this, that was our starting point. And 1 year ago, something like that, I presented our ongoing migration plans, which were to be going towards cluster API, because everyone was doing that. Cluster API was discussed this morning. There was also a talk on managing lots of clusters, multiple dynamic clusters. Cluster API, the idea is that you have a Kubernetes management cluster on which you manage your workload clusters. So the idea is that instead of having a deployment for pods, you have machine deployments for machines, the machines being your nodes. And so we plan to go with that, with these prospects. And then at the same time, we had to reconsider our choice, because Cider Labs, they pivoted away. They had cluster API providers, so to generate all the configuration that you need to manage your Talos nodes. But they migrated away from it for reasons which we can understand. Well, first of all, they moved their focus to their own business source offering, which is called Omni, which is kind of analogous to cluster API, but really dedicated to Talos, and which we've tested, really works well, but we didn't really like, because it acts as an authentication authorization proxy in front of your Kubernetes API server, which we really didn't want to have. And so, yeah, from that perspective, they were not going to invest as much time in the cluster API part of Talos, and it was quite a risk to go like that. And so then we had an issue, because we really wanted to go with Talos Linux, but we didn't really want to go with Omni for the reason I just mentioned, and we obviously didn't want to wrap Talos-ctl. So Talos-ctl is the tool that you use to manage your Talos nodes. We didn't want to wrap that in Ansible. We had enough Ansible at that point in time, and then we thought about building a purpose-built tool for Talos, and that's when we went to the whiteboard and we started to draw things. I'm not sure how much you can I guess you can guess what it does. So the central part is TOPF, and the idea that we had is that we want to open source this because then we get issues, discussions around the tool, which might be beneficial for us in the long term. So we have to make sure from the get-go that we are going to decouple the parts which are really which we cannot open source, like our secrets integration or infrastructure provider integration, where this is not helpful to anybody and we cannot share that as an open source. But the core part of TOPF, of seeing how it was called back then, we wanted to try to open source it. And that's what we managed. So that's what we built, TOPF, Talos Orchestrator by PostFinance. It's not an operator, it's not a controller, it's not shiny, it's just a stupid CLI, which does all we need to manage our nodes. Basically, I don't want to compare it to Ansible, but it's a bit like Ansible, but supercharged and really dedicated to Talos Linux. It's written in Go. It directly uses the Talos CTL Go SDK, so we directly called the gRPC API that I mentioned before, and we use that tool to manage our clusters as of now. For those who have used Talos, you know that there are a few commands with the command line. So Talos CTL apply. The idea with that one is that you have a machine configuration and you apply it to a node. This would be like uploading a config file on a standard Linux and then reloading the service. So Talos CTL apply is one of the commands. Talos CTL upgrade is there to update the OS or the operating system itself. So to upgrade Talos Linux so that it loads, for example, a new container D or a new Linux kernel version. Talos CTL reset to reset the cluster. So all those commands are already there, but with Talos CTL, all those commands typically target one node at a time. So you can have solutions where you would wrap that in Ansible or with a bash script to process all your nodes one after the other. And what we did instead was do that, but in Go, because this is much faster and much more fun to write and much simpler to maintain as well. And so we introduced, I guess, the core functionality or feature of TOPF is the configuration model, the GitOps patch management, or the layered YAML configuration model. I will get to that in an instance with a few examples. And then, as I mentioned, we directly introduced the possibility to have your inventory in any type of form, actually. All you need, I will cover that later. It's going to be easier with an example. And yeah, we do a lot of checks, because if you do just a Talos CTL apply, it's going to apply the config and boom, that's it. Perhaps you've just destroyed the network of that node, and perhaps you're going to do all the nodes at once, and then you've crashed your cluster. So obviously we did some safeguards. After we have applied the change, we want to make sure we have some post-apply checks which run and which wait for 30 seconds that the node is really ready, stable, and so before we proceed to the next node. This is something that was missing from the Talos CTL CLI. So let's get to the patch layered YAML patches model. In blue, we have really the entry point, the top of the YAML file, where you define your cluster name, your cluster endpoint, which Talos version you want to run, which Kubernetes version you want to run, because those are not the same. They're not they are coupled, but not so tightly coupled. You can mix and match, and then you define your nodes if you want to have them in a YAML file. So you define just one control plane node to start, and then you need to have one of the first configuration change that you need with Talos Linux is that you need to specify the installation disk. In this case, I'm running that, for example, if you have a normal disk, it's going to be dev SDA, it could be NVMe and 0 or something like that. Because when you boot a Talos, when you boot a VM and you boot an ISO for Talos Linux, for example, you need to decide where you are going to install it. That's all you need to know. And as we can see here, so we have this top.yaml, and then we have a folder all, and this all folder is going to contain configuration patches which are applied to all nodes. As we'll see afterwards, we can override per node as well, but that's the simplest that you need to get started with a Talos clusters, and that's what I will demo afterwards. Then you can have a bit more complexity in there. For example, let's say my control plane node, I want to allow scheduling on them because I just have a homelab with 3 nodes. They're all going to be a control plane nodes, and I want workloads to be running on there. So in the control plane folder, I just create a patch to for the configuration part. So the thing that you have on the right hand side is really taken straight out of the Talos API reference. It's really you go there on the Talos website, and they have the so-called machine configuration document where you have all the configuration toggles and options that you need to steer your Talos node. So you go there, you check, okay, how do I enable the control plane to be running workloads? You find that it is cluster.allow scheduling on control planes. You set this to true. And because it doesn't make sense to apply dispatch to the worker nodes, you just put dispatch in the control plane folder. Then you might also want a patch for a GPU node, for example, which would only be for for all your worker nodes, for example. So you would put dispatch in this folder. That's the purple patch that we have here, where you would say, okay, we have an NVIDIA card. We need to load some kernel drivers, kernel modules to make use of that card. So that's what you get with like role level layers or overlay. And then you can also have template patches, which is something quite convenient. I guess you can either go template or use Prig. That's pretty new. So in your top of the channel, you can have some data fields, either global to the cluster or just per node overrides. And then you can use that in a template file. For example, you can specify the provider ID extra args for kubelets, which permits us to get rid of the vSphere Cloud Provider interface, because we have an inventory. We know exactly the UUID of our VM, and then we can directly plug it in the kubelet provider ID here, and that's it. Our node boots, and then we can directly we need one less component because we are able to template data like that. Also, you can have per node override. So in the node folder, you can create subfolder for each node, and then you can have a patch which will only be applied to that subnode or subfolder, which is quite convenient if you want to test, for example, a new Talos version or a new config file, a new config flag, or new sysctl, whatever, on just one node. You don't want to roll that at all nodes at first, so you just put it in the folder of the node. So I guess with it, let's go to a live demo. Let's see how much it breaks or if it works at all, but I hope it works. So I'm running 2 VMs on UTM. So for those who have never seen Talos Linux, that's what you get when you boot a Talos Linux VM. This one I cannot enlarge, the one should be a bit bigger. So this is the Talos dashboard. And so we see on the top left corner, the stage is maintenance, which means that the node is waiting for some configuration to land on it. It's not doing anything active. It's like you've booted your Ubuntu and nothing is there. So we have 2 nodes in maintenance mode. And we have this minimal top of the YAML that I've showed before. So I've named the cluster TOPF demo. The cluster endpoint is the IP address of the control plane node. My control plane node, I will name it as Talos CP1. And then on the left-hand side, we have 2 patches. So the first one is the install disk. Here it's going to be VDA because it's a virtual drive, and that's how Linux recognized the disk provided by UTM. And then I have a hostname patch. This here is how you specify the hostname for Talos Linux node. So again, you would go to the Caesar Labs Talos website, check their documentation, the reference implementations, and then you would see, how do I configure the hostname? Well, you have to create a hostname configuration document. YAML, I think we all love YAML by now, or at least we're used to working with it. We said that we don't want the name to be automatic, otherwise it will generate a new name when you install the node. You want the name to be that which we template like that. So .node.host is going to be what you have here. So with that, we should be able to apply that configuration document. I'm also enabling the auto bootstrap flag. Bootstrapping for Talos Linux nodes, the idea is that if you just apply a machine configuration for a control plane node, it's going to start etcd, but it's not going to it's going to start an empty etcd, but it's not starting to write into it until you run the talosctl bootstrap command, because you could at that point also say talosctl bootstrap from snapshot if you wanted to restore, which is super convenient. So we've just built a small flag to automatically bootstrap, because most of the time you want to bootstrap when you provision a new cluster. So let's try to run this command, TOPF apply auto bootstrap. So the first prompt I get is no secrets YAML found for the cluster TOPF demo. So it's a new cluster. We need to generate a new secrets bundle. So we'll let it do that. So if it has done that, and now it has tried to do a dry run apply. So sent the configuration to the node, and the node replied with what would change compared to what was now. So there was nothing on the node, so obviously lots of stuff is going to change. Lots of the diff contains a lot of buses. And we also see, this is one of the small functionalities of TOPF. When you make a dry run diff, it will redact all the secrets that it has gathered. So we have built some logic to prevent having your like cluster CA keys from getting into your logs. Okay, so we apply a lot of stuff. Here at the bottom, we see the hostname config, control plane one. So let's let it do it. And then we see starting the bootstrap process. It's waiting. Let's check the control plane node dashboard. So we see some stuff is happening. It has pulled the Talos Linux installer image, which is around 220 megabytes for a new image, for a new install. If you don't have any kernel modules special like NVIDIA, which then it's a bit more, but it's not that much. 120 megabytes for an operating system. I guess we all agree that's pretty small. And so we see here it has rendered some static pod manifest. So perhaps we already have a Kubernetes server. I see we have had the bootstrap, which was complete. Let's check if we have nodes. So, well, first of all, we don't have anything because I don't have a kubeconfig file. So for that, I can just do topf kubeconfig, which will generate a kubeconfig file. Normally, I should already have the proper environment variable. Yeah. So now we have the stage where we have no nodes, but we have an API server. It boots so fast that you already see the namespaces, although there is no node yet, which is something that even didn't know that this cluster could run without any node, but actually why not? The API server is something else than the node. And so if we go back to the control plane node here, we saw that it has failed a few times to register the nodes in the API server, but because it is a controller, it's going to retry over and over until we have the node here which just joined the cluster. So we have a control plane node in there with, well, the basic control plane components. Well, I guess we have taken 2 minutes to start control plane nodes on a five years old laptop, which is not bad. Let's get to the next part of this demo. Have some commits prepared. Let's add a worker node. So one worker node, and we add a label, for example, region Zurich. So Talos worker 1, let's run the apply command, like that. So topf apply, let's see what happens. Again, it prompts me for the changes that are going to happen on that node. We see it's going to be called Talos worker 1, so let's just apply that one. We can then check on the node itself what's happening. We see pulling image, GHCR, IO, CDO Labs kubelet. So it's pulling the kubelet image for because everything is packaged as OCI images with Talos. You don't pull the kubelet binary from dpkg or from the Debian repos or whatever. You just everything, they all package that as OCI images. And here we go. We have already a node which has joined. So if we go back there, K9S again, we should have 2 nodes, one of them not yet work. Well, it's already ready actually. So 30 seconds later, we have a 2 nodes cluster. What I didn't show is that I had this data region Zurich. So I didn't show where we were using that. So in here we have a label template where we insert the data.region field of that node. So let's check if we indeed have that label at postfinance.region. So let's search for region. Postfinance.region, we see that we have Zurich. And if I were to do one last example, we have, for example, an example where we needed to do that this week actually. One of our developers on the dev environment wanted to have this kernel Linux security module configured to 1, which would allow to trace child processes. By default, it was 2 on Talos Linux, which is quite strict on security, and we decided to allow it to 1 on that cluster. So we just added something like that, data allow ptrace, so we can decide which nodes would have this sysctl configured. And then it's going to be another matter of topf apply. And we see, okay, it's going to apply new sysctls. Here we do not have the one with the ptrace because it's the control plane node. And if I run the same command over, we have here kernel yama ptrace scope 1. That's the thing that got templated from here because in the node data we had this allow ptrace field set to true. So yeah, that concludes the demo part, I guess. We might get back to it if we have more time, but I guess this is not going to happen. So this showed you a bit what you can do with TOPF. Basically, it helps you manage your Talos nodes from the command line, but you can obviously run that in a CI as we'll show later. What's been new? So we launched Talos, I think, February or March this year. Now we have 60 stars. I count on all of you to increase that number by a bit. We had some user requests, for example, Val's secret resolution. Helm/Vals is a project which basically lets you retrieve secrets from a lot of backends, to not say 90% of the secret storage stores that exist. You can retrieve through Vals. So we implemented that, and it's quite convenient. You can just say you have your YAML file, you just use ref plus and then your backend and then the pass in the backend, then you can like get a secret directly into your configs. We also added Sprig templating, which lets you do a bit more stuff than just Go templating. And then this one is quite convenient as well. Beforehand, so when you want to create a new Talos machine, you need to pick which extensions you want. So you have to select those extensions on the Talos factory website, and then it will generate a schematic ID, which is just the SHA-256 checksum of the schematic that you have on the left-hand side. So the schematic is really the part where it starts at customization, system extension, and then you could also have extra kernel arguments and everything. And so it generates a schematic ID, which is not so convenient just having just having a hash in your config. It didn't please us, so we implemented something where we can either you specify the schematic ID in TOPF to be really the checksum, or you specify it to be a pass. So with this arrow at and the pass to the manifest, and then we are going to pass it with the Talos SDK, and then generate the SHA-256 sum if it's a valid one, and we can even submit it to the factory if you need to. So that's one of the new features. And something I wanted to cover is the dynamic providers, which basically makes the step from I run TOPF at home with a few servers, so having the node list in TOPF.yaml is fine, it's static, it doesn't change every day, to I want to run TOPF in a production environment at my company where there are lots of servers. So you have two integrations. You have a nodes provider, and then this is going typically to be a binary that you write, which retrieves, TOPF sends it the cluster name, and then the provider, its role is to return the YAML file which contains all the nodes, with all the nodes attributes. So for example, the provider ID and all that stuff. You write it, you do whatever you want with it. You go fetch whichever API you like. You can build some of them together. That's your work to do. And then the secret provider, same idea here. You integrate into whichever secret store you want, or you could also use now the Vals integration that I showed before. So those are some of the features of TOPF. And finally, we run it in a GitLab environment. So what we do every morning or every change, we have a TOPF apply dry run which goes. So we know then we check the logs of the job, and then we know exactly, okay, for those nodes we are going to change this ccTL parameter. For those nodes we have nothing to do because it's already being done. And so this is always this doesn't cost anything, this doesn't risk anything because it's just a dry run. And then the manual step is going to be the actual apply, where after having reviewed the logs in GitLab, we decide, okay, those changes, we really wanted them to be there, so let's click the apply button, and then it will go one node at a time, or even now we have also implemented parallel nodes because we have some large clusters. And so, but it does those nodes, and then it checks, it applies the config, it checks, is the node still healthy? Yeah, then we can continue to the next node, and so on and so forth. And the same goes for the upgrades. You can do TOPF upgrade, and that is going to do exactly the same process for upgrading all your Talos nodes. So the alternatives that we would have considered would be, well, script Ansible. This was more like we needed something on the left-hand side, but never ever Ansible for us. Tal Helper is quite good, but they ended up with an approach where you still have to run all the commands manually. You can, of course, use bash scripts to glue that together, but it was not as integrated as we liked, and the configuration model was not that of the Talos documentation. It's like an intermittent level between the Talos configuration model and what they have. Whereas with TOPF, we have really something that you just look the documentation from Talos, and then you can just take their example, copy paste that in your all folder or whichever folder you need the patch to be applied to, and then it's going to do what you expect it to do. And finally, there is Omni, which we, as I mentioned before, quite liked, but it's the turnkey solution, but it introduces an authentication and authorization proxy. And I guess I don't have much time left, but I think the hard part is not the operating system. It's much simpler with Talos, but the hard part is the lifecycle. How do you manage new nodes? How do you apply new updates, new configuration changes, and make sure that you don't break everything? So yeah, that would be it. We are at the end of this session, and I'm ready if you have some questions, if you have time, up to you. Thanks.